Okay, so that video timed out on us, but the idea is if I create a x and y coordinate plane, I have 3 units to the right, up, left, and down. If I were to connect all the way around at my 1 unit values out, so I'm going, my radius here is 1, all these points on my x and y axes are easy to plot, because this point right here, wouldn't that be point 1, 0? And this top point, if I write it as an ordered pair, be 0, 1. This value right here would also be -1, 0. And this value right here would be 0, -1. So the idea is that we can actually take this to our quadrantal angles. Because on the edges of our quadrantal angles, we're going to assume from our center straight up to this point, to the right to this point, to the left of this point, and down, we're going to assume, just like we did, let me get that in focus for you. So we're going to assume that from our center that all 4 of these points are 1 unit away, just like we did or looked at in our unit circle from before, that all 4 of these points are 1 unit away. We can assume that this point can be represented as 1, 0. We'll start with that first, 0 degrees and 360. So this distance right here, this is my initial side, okay, my initial angle, my initial side of my angle, and then right on top I have the orange, okay? That would be an arrow, or I'm sorry, an angle that would represent 0 degrees, or if it went 1 full time around your coordinate plane, it would represent 360 degrees. But at this point, you know that your radius is 1, because that's the distance of your radius, and your x and y are both represented as that ordered pair, okay? So at 0 degrees or 360, I can actually come up with the sine, cosine, and tangent of 0 or 360 degrees by just as having this information. Because your your sine is your y over r proportion, your cosine is your x over r, and your tangent is your y over x. So if I plug in these values, y at 0 degrees, your y value is 0. Your r value is always 1, and 0 divided by 1 is 0. Cosine of 0 degrees is x, the proportion of x over r. In this case, at 0 degrees, x is 1. Your radius will always be 1. So cosine of 0 will forever be equal to 1. And tangent is y over x. So 0 over 1 gives you 0. So what I'd like you guys to do is take that information and we're going to fill it in on part 3. And again, 0 and 360 are coterminal, so they can be interchanged. So sine of 0 or sine of 360 will forever be equal to 0. Actually, what you guys can write, you guys can fill this in. You can fill in here what we have over here. So y over r is equal to 0 over 1, which is equal to 0. Cosine is x over r, which is 1 over 1, which is equal to 1. And tangent of 0 is y over x, which is 0 over 1, which is equal to 0. So you're basically writing what sine, cosine, and tangent are for 0 degrees or 360. Okay? So, moving straight forward, the green is still your initial side, but now we're going to be looking at 90 degrees. So now we have the orange leg that's straight up. And this point is represented, like we talked about below, as 0, 1. So your x is 0, your y is 1, and your radius will forever be 1. So if I continue on, sine of 90 is equal to y over r, which in this case is 1 over 1, which is 1. Cosine of 90 is equal to x over r, which in this case is 0 over 1, or 0. And tangent of 90 is equal to y over x, which in this case is 1 over 0. And 1, or in your fractions, you can never have 0 in your denominator, so we're going to call this undefined. So your tangent at 90 degrees is undefined, and we'll eventually get to talking about why that is true a little bit down the road when we start talking about graphing. So at this point, we can fill in sine of 90 degrees will forever be 1, cosine of 90 degrees will forever be 0, and tangent of 90 degrees will forever be undefined. Moving on, we move counterclockwise to 180 degrees. This point right here is represented as negative 1, 0. Your radius is equal to 1. And we can continue on with sine, cosine, and tangent of 180 degrees. Sine is y over r. So I'm not going to rewrite it because I have it up here. Y in this case is 0 over 1, which is 0. Cosine is x over r. So in this case we get negative 1 over 1, which is negative 1. And tangent is y over x. So in this case we get 0 over 1, over negative 1, I should say. Both of these should be negative 1, which is equal to 0. So sine of 180 is 0. Cosine of 180 is negative 1. Tangent of 180 is 0. Last but not least, we have 270 degrees. So if you continue going in this direction, your initial green side is right there. So if we continue to go around to 270, we know that 270 at that point is 0, negative 1, and your radius is equal to 1. So if we continue with that same thought process as before, sine of 270 is equal to y over r. So y is negative 1 over r, which is 1, which is negative 1. Cosine of 270 is equal to x over r. So we get 0 over 1, which is 0, and tangent of 270 is equal to y over x, which is negative 1 over 0, which we know is undefined. I just caught a mistake I said earlier, so this is your radius. This should actually be positive 1. Okay. So filling in sine of 270 is negative 1. Cosine of 270 is 0, and tangent of 270 is undefined. A couple key things I want to point out a little bit about tangent all of a sudden is the idea that tangent deals with your y over x. And this might be getting a little bit more involved, but I just want to put that little bird in your ear just so that you kind of, once we start talking about graphing, you can kind of see some correlations. If y is equal to mx plus b, I'm just going to leave it as y equals mx. That actually represents a line with slope. And if I divided both sides by x, my slope of my line is actually represented by the y over x line. Okay? So it's no wonder that when you connect your tangents that it kind of correlates to the idea of a positive and negative slope. Similarly, if you're looking at tangent, if you look at your x-axis, your horizontal line, in both of these cases, your tangents are actually equal to 0, which matches the fact that when you have a horizontal line, you have a 0 slope. It also coordinates with the fact that when you have a vertical line, if you think back to Algebra 1, when you have a vertical line, you actually have an undefined slope. And so it makes sense that when you connect the degrees of 90 and 270 together, that you're going to have tangent for both of them being undefined, since your slope between them would essentially be like an undefined. So that's kind of an easy way to remember those tangents at those quadrantal angles. So if you connect 180 and 0 degrees or 360 degrees, you get a horizontal line. And in cases of the slope, which is like your tangent, you're going to have 0 tangents along that line. connect your two quadrantals on your vertical line, 90 and 270, you will always have an undefined tangent for those. So just a couple key things to think about as we move forward. So let's get into the unit circle and filling out our unit circle the best we can. So the idea of the unit circle is we have some key pieces of information we want on here. The first is, and I'm going to zoom out a little bit so I get as much of this in as possible. So the idea of the unit circle is we have your quadrantal angles, which are 0 and 360, 90 degrees, 180 degrees, 270, and back to 360. So it's kind of like a quadrant 1, a quadrant 2, quadrant 3, and a quadrant 4. And the idea of your quadrantal angles is that they don't fall in a quadrant. They're actually on your axes between quadrants. That's why they're called quadrantal. But in each quadrant, you have positive and negative values for your sine, cosine, and tangent. So in each of my corners, I'm just going to really quickly represent what my sine, cosine, and tangent functions should be, because this unit circle is your cheat sheet, your resource to use for the rest of the year in terms of the trig unit. So in quadrant 1, I know that sine will always be positive, cosine will always be positive, tangent will always be positive. In quadrant 2, I know that sine will always be positive, cosine will always be, negative, and tangent will always be negative. I also know that in quadrant 3, sine will always be negative, cosine will always be negative, and tangent will always be positive. And in quadrant 4, sine will always be negative, cosine will always be positive, and tangent will always be negative. Okay, so let's just go around and fill in on our unit circle what our sine, cosine, and tangent functions are for each of the quadrantal angles. So at 0, 360, I know at 0 and 360, sine of 0 will always be 0. We can also use them interchangeably for 360. Cosine of 0 will always be 1, and tangent of 0 will always be 0. I can also replace those with 360 and still get those same values. At 90 degrees, I know that my sine of 90 will always be 1. Cosine of 90 will always be 0, and I'll write underneath it, tangent of 90 will always be undefined. Continuing on to 180, sine of 180 will always be equal to 0, cosine of 180 will always be negative 1, and tangent of 180 will always be 0. And last but not least, 270, so sine of 270 will always be negative 1, cosine of 270 will always be 0, and tangent of 270 will always be undefined. So you should have at this point your unit circle filled out to the best of your knowledge in terms of your quadrantal angles as well as your sine, cosine, and tangent values at those angles. So moving forward, we now talked about our quadrantal angles, but now we need to jump in and talk about the angles in our quadrants. And in our quadrants, we have 3 little splices. And before we get started on that, I'm going to pull that off to the side. I'm actually going to bring in the last sheet we need for this discussion. And the idea is trig comes from the idea of triangles. So it makes sense that we're going to pull back from the very first couple weeks of school. We talked about special right triangles, and I know you guys semi-remember what that is. So you have 2 special right triangles, and those are the 45, 45, 90, and the 30, 60, 90 triangles. And if you recall, and I know you have this on the sheet, but I'm just going to redo it so that it looks a little bit more familiar to you from class. But in this particular special right triangles, if you have 45 degrees, so it's an isosceles right triangle, we know that whatever one of our legs are, we'll call it x, the other leg will also be x, right? So for example, if this leg here was 10, this leg right here would also be 10. The relationship between these two legs and your hypotenuse is always 10 times the square root of 2. So if this is 10, this would be 10. Your hypotenuse would then be 10 times the square root of 2. 30, 60, 90, if you recall, your smallest angle in this particular case would be 30. So your smallest leg would be opposite of 30. Smallest leg will represent as x. And your smallest leg and your biggest side, which is your hypotenuse, are always related by being doubled. So your smallest side and your hypotenuse are always going to either be doubled or half, depending on how you look at it. So your smallest side length, if we call that x, your hypotenuse will always be twice that size. So if x in this case is 10, your hypotenuse is 20. If your leg opposite of 30 here was 15, your hypotenuse would be 30. The relationship with your middle angle, which is 60, will always be x times the square root of 3. Now I have a little trick that I shared with you before, and I'm going to just restate it again. It's not really a mathematical trick, but it's just something that kind of helped me remind myself, because these two look very similar to each other. I picked the x square root of 2, obviously, with the special right triangle that has the two 45s, and I have the square root of 3 leg with the right triangle that clearly has the 30, 60, 90 that goes up by 3's for each of those triangles, or each of those angles. So moving forward, the idea here is that we're looking at these special right triangles because they kind of help us with our unit circle. So of these angles, what angles have we already found sine, cosine, and tangent functions our values for? And the answer is we already found values for sine, cosine, and tangent for 90 degrees. 45 is repeated, so I'm going to cross out one of those 45s. So now we're going to try to find sine, cosine, and tangent for 30 degrees, 45 degrees, and 60 degrees of your special right triangles. Okay? Before we do that, though, we're dealing with a unit circle. And in a unit circle, we're dealing with a radius of 1. So for the time being, I'm actually going to replace each of my x's with a 1. Okay? So in this case, if I redraw my 45, 45, 90, I'll put the 45 in the corners. If this side length is 1, I know that this side length is 1. And more importantly, I know that my hypotenuse is going to be 1 times the square root of 2. Since 1 times the square root of 2 is basically just the square root of 2. If I take my 30, 60 right triangle, 30 up top, 60 down below, if my shortest side length is 1, I know my hypotenuse is going to be 2 times that 1, which is 2. And opposite of 60 is going to be 1 times the square root of 3, which is just the square root of 3. Since we're not in an x and y coordinate plane, I'm going to go back to my SOHCAHTOA. And you guys remember SOHCAHTOA is opposite, hypotenuse, and adjacent. So let's start with, and so just before we move on, this that I drew on the sheet of paper is no different than that in-class discussion sheet that I gave you. The only difference here is that they're using n instead of x. So we're basically using what I have on my sheet of paper are these two outlines right here. Okay, but I'm going to continue working on my sheet of paper from before, but we're going to be filling in this bottom table in a couple minutes because we're going to find sine, cosine, and tangent for each of these angles. So going back to my original drawing, I'm going to slide this up. Let's start with 30 degrees. So we're actually going to start with 30 degrees. And we're going to find the sine of 30, cosine of 30, and tangent of 30. Okay? And sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So the first thing we need to do is we need to label our sides opposite, hypotenuse, and adjacent. So opposite of 30 is the 1, so we have opposite over here. Adjacent to 30 is the square root of 3, and our hypotenuse in this case is 2. So if we fill in that piece of information, opposite over hypotenuse, we have our opposite, which is 1, over hypotenuse, which is 2. So the sine of 30 is 1/2. So we can fill that in on the second sheet. Sine of 30 is 1/2. Moving on to cosine. Cosine is adjacent over hypotenuse. Well, my adjacent is square root of 3 over hypotenuse, which is 2. So your cosine of 30 will always be the square root of 3 over 2. And tangent is your opposite over adjacent. So opposite in this case is 1 over adjacent, which is square root of 3. We know we can never have square roots in our denominator, so to rationalize that, we take square root of 3 times the top and bottom. So 1 times square root of 3 is square root of 3. Square root of 3 times square root of 3 is square root of 9, which is 3. So tangent of 30 is square root of 3 over 3. So we got 30 degrees done. So now let's go to 45 degrees. 45 degrees, so we got sine of 45, cosine of 45, and tangent of 45. Okay, so obviously it doesn't matter which 45 we pick, so let's go with the upper one. So this one is going to be our opposite leg, this one is our adjacent leg, and we obviously know our hypotenuse. So since sine is opposite over hypotenuse is 1 over square root of 2. Just like we just did with the tangent of 30, top and bottom, we have to multiply by the square root of 2. So sine of 45 gives us square root of 2 all over the square root of 4, which is 2. Cosine of 45 is adjacent over hypotenuse. Our adjacent over hypotenuse is 1 over square root of 2, which is the exact same thing as the sine of 45. So we know that we're going to have the square root of 2 over 2 for both sine and cosine of 45. So we can fill in square root of 2 over 2, square root of 2 over 2. And doesn't it make sense that our sine and cosine would actually be the exact same value since our opposite and adjacent sides are the exact same value? Last but not least, tangent of 45 is opposite over adjacent. In this case, it's going to be 1 over 1, which just simply reduces to 1. Last but not least, let's look at 60. All right, I'm going to scroll up just a little bit so that we get a little bit more room here to write for 60 degrees. So we're going to do the sine of 60, cosine of 60, and tangent of 60. So the cosine of 60, again, is opposite over hypotenuse, but before we can do anything, we actually have to change, since 60 is a different angle, is the opposite angle of 30, we actually have to change our legs here, because 1 is not opposite. 1, according to 60, is actually the adjacent side, and square root of 3 is our opposite side, and our hypotenuse doesn't change. So once we have a chance to switch those two sides, sine is opposite over hypotenuse, which is square root of 3 over hypotenuse, which is 2. Cosine of 60 is adjacent over hypotenuse, which is 1/2. And tangent of 60 is opposite over adjacent, which is square root of 3 over 1, or just the square root of 3. So if I fill in my chart, sine of 60 is square root of 3 over 2. Cosine of 60 is 1/2. And tangent of 60 is square root of 3. Really quick before we move on, I just want to point out the relationship between 60 and 30 degrees. Sine of 30 and cosine of 60 are the same. Cosine of 30 and sine of 60 are the same, which makes sense since your adjacent and your opposite sides swapped when we looked at the different angles. So at this point, we have the sine, cosine, and tangent values of those 3 new angles. And those 3 new angles are going to help us fill in the rest of our unit circle. So I'm going to have you guys take this sheet of paper that's already filled out and just kind of move it off to the right, and we're going to fill in the rest of our unit circle and the degrees around our unit circle. So starting with our first increment, in terms of 30, 45, and 60 degrees, we would expect that this first angle right here to represent 30 degrees, right? Because we just talked about the 3 new angles, which means the next one in line would obviously be the 45 degrees, and then the next one in line would be the 60 degrees. So just in quadrant 1, the bigger increment represents 30 degrees change, and the smaller ones represent 15. So if we're looking at quadrant 1, can't we figure out quadrant 2, 3, and 4? All we have to do is continue through the rest of those units. Each of the bigger ones being 30 units difference, and then the smaller increments being 15. So from 0 to 30, that's 30. 15 more would be 45. 15 more would be 60. And then 30 more would be 90. If we continue around their circle, 30 over would actually give us 120 degrees. Add 15 degrees onto that, we would actually get 135 degrees. Add 15 onto that, we actually get 150 degrees. And then another 30 brings us to 180. Continuing through quadrant 3, if we add 30 onto that, we actually get 210 degrees. Another 15 onto that will give you 225 degrees. Another 15 onto that will give you 240 degrees. And another 30 would give you 270. Continue around, add another 30 on, you get 300 degrees. Another 15 would be 315 degrees. And another 15 would give you 330 degrees. Another 30 onto that would give you one full circle, which would be 360 degrees. So we just filled in all 4 quadrants and those special angles that we just found using the special right triangles of the 45, 45, 90, and 30, 60, 90. Okay? So continuing on, since we know quadrant 1, we actually know the sine, cosine, and tangent functions of these already. So let's fill those in. We know that the sine of 30 is equal to, so we're going to look back at our sheet. So the sine of 30 is equal to 1/2. We know that the cosine of 30, if we look back at our sheet, is square root of 3 over 2. And we also know that the tangent of 30 is equal to, if we look back, we get square root of 3 over 3. And now we have all 3 trig functions for 30 degrees. Continuing on, sine of 45 degrees. We look back at that same sheet we just looked at from before. Sine of 45 is square root of 2 over 2. Cosine we know is going to be the same for 45 degrees, so we get square root of 2 over 2. And tangent of 45 is going to be 1. Last but not least, we can go to 60 and fill in 60. Sine of 60 degrees is going to be square root of 3 over 2. Cosine of 60 degrees is going to be 1/2. And the tangent of 60 is equal to square root of 3. Because we're in quadrant 1 has sine, cosine, tangent that are all positive. But now if we move to quadrant 2, if we take quadrant 1 and we flip it over on top of quadrant 2, what you're going to notice is that 60 is going to lay on 120, 45 is going to lay on to 135, and 30 is going to lay on to 150. More importantly, and I'm going to do this with pen because I don't want to mark up the unit circle, if I were to create the angle at 120, this is another thing dealing with the reference angle. That degree angle with the 2 pens, this degree in the middle represents 120, which means the other side to get to 180, isn't that 60 degrees? So your reference angle here is 60 degrees, which is going to match what your sine, cosine, and tangent of 60 degrees is going to be. So quadrant 1, if you know quadrant 1, you actually know the whole circle, because we can keep taking these quadrants and laying them over on top of each of the quadrants and flipping them over. So your sine, cosine, and tangent functions are going to the values are going to be all the same. The only thing that changes is the positive and negative values depending on which quadrant you're in. So if we take 60 over 120, I'm going to write this kind of sideways. I'm actually going to rotate it to kind of write it. So I'm going to take 60 laid over 120. So I know that the sine of 120 is equal to the exact same value that 60 would be, and it's going to stay positive. So I'm going to get square root of 3 over 2. Cosine of 120 is going to be negative now because we're in quadrant 2. It'll be 1/2. And I'll do tangent up top. Tangent of 120 is going to be negative in quadrant 2. So tangent of 60 square root of 3, which means tangent of 120 is going to be a negative square root of 3. I know some of you guys are running out of room a little bit. So let's look at 135. If we take 45 degrees and lay it over 135, we actually get your sine is positive. So sine of 135 is going to be square root of 2 over 2. Cosine of 135 is square root of 2 over 2. And tangent, negative square root of 2 over 2, because cosines are all negative in quadrant 2. So this cosine should actually be negative 1/2. So sines are all positive, cosines are all negative. Tangents, so tangent of 45 is 1, so tangent of 135 is going to be negative 1. 30 degrees lays over 150 degrees, so your sine of 150 is going to be positive 1/2. Cosine of 150 is going to be negative square root of 3 over 2. And tangent of 150 is going to be negative square root of 3 over 3. Alright, so we're going to zoom in a little bit so it makes it a little bit easier to see. 180, we already have sine, cosine, and tangent for. Now in quadrant 2, if I take quadrant 2 and lay it over quadrant 3, 150 is going to lay on top of 210. So the numbers are going to be the same. What's going to change, though, is the sine, cosine, and tangent functions. Because sine, cosine, and tangent for quadrant 3, it's negative, negative, positive. So your sine, actually let me see if I can squeeze it in a little bit better. Your sine of 210 is going to be the same value as 150. The difference is it's going to be negative now, so it should be negative 1/2. Cosine of 210 is going to be negative square root of 3 over 2. And tangent of 210 is going to be positive now, so it's going to be positive square root of 3 over 3. Moving around to 225 matches with 135, which matched with 45. So sine of 225 is going to be a negative square root of 2 over 2. Cosine of 225 is going to be a negative square root of 2 over 2. And tangent of 225 is going to be a positive 1. I'm going to keep rotating this. 240, if you lay 120 on top of 240, you're going to have the same values. So sine of 240 is going to be a negative square root of 3 over 2. Cosine of 240 is going to be a negative 1/2. And your tangent of 240 is going to be a positive square root of 3. Continue rotating this around. 240 lays on top of 300. So the only thing that changes here is your sine, cosine, and tangent functions of quadrant 4. So if I rotate this around, sine of 300, so you take your sine of 240, it lays on top of 300. Sine is still negative, so you're going to get negative square root of 3 over 2. Cosine of 300 is positive now, so it's going to be a positive 1/2. And tangent of 300 is going to be negative square root of 3. Rotating around, 315 matches with 225. So sine of 315 is going to be a negative square root of 2 over 2. Cosine of 315 is positive square root of 2 over 2. And tangent of 315 is a negative 1. And last but not least, I'm not going to write this upside down. We'll have another unit circle where we'll have a little bit more room. But now we've got 330, which is 210 right on top of that. So sine of 330, again, is a negative. So 210 was a negative 1/2, so it's going to be negative 1/2. Cosine of 330 is going to be a positive square root of 3 over 2. And tangent of 330 is going to be a negative square root of 3 over 3. I'm going to zoom out, but the idea is we just filled out a reference cheat sheet resource for you that's going to come in so handy as we start diving into more trig functions and getting into graphing and dealing with what these trig functions are really all about. I know this was a pretty lengthy video, pretty lengthy conversation, but the idea here is that you understand the resource that you're using. If I just gave you a resource and you had no idea how to use it, you really wouldn't get the full benefit and understanding what these trig functions are. So we just built for yourself a cheat sheet and a reference piece that will be very useful to you throughout the rest of the trig unit. And we will talk about more questions and a couple other things in class the next time that we meet. So keep these sheets of paper for our next class. And this completes our unit circle number 1 discussion.